Hello there, and welcome to Cosmic Sleep Stories. I'm so glad you found your way here tonight. Maybe you've looked up at the stars and wondered what invisible forces shape our galaxy. Or perhaps you're curious about the hidden structures that have been protecting our cosmic home for billions of years. Either way, you're exactly where you need to be. You can rest now. Tonight, you have nothing to do but let go. Let your breathing slow, steady as the ancient rhythms of the galaxy itself. Let your body relax, sinking into comfort like a star settling into its orbit. Let your mind drift outward, beyond Earth, beyond the solar system, into the vast spiral of the Milky Way where invisible shields have been standing guard since before our sun was born. Over the next 2 hours, we'll journey together through 3 remarkable discoveries that changed how we understand our galaxy. We'll explore a massive envelope of superheated gas protecting small galaxies from destruction. We'll visit the containment system surrounding the supermassive black hole at our galaxy's center, trapping radiation that could flood thousands of light years. And we'll discover the mysterious patterns at the galactic boundary that reveal how our galaxy interacts with the universe beyond. These aren't force fields from science fiction. They're real physical phenomena created by hot gas, magnetic fields, and the motion of matter through space. Natural structures that arose from the laws of physics, operating quietly for 13 billion years while we had no idea they were there. Some facts will captivate you. Others will simply wash over you like cosmic rays through space, leaving only soft impressions as you drift towards sleep. And that's perfectly fine. There's no need to remember every detail. Just let yourself be carried by the wonder of it all, by the deep comfort of knowing that our galaxy has been protected, has been stable, has been safe enough for stars and planets and life to exist. And before we begin our journey through these invisible shields, if these quiet cosmic explorations help you unwind at the end of your day, consider subscribing to Cosmic Sleep Stories. It helps others find this peaceful corner of the universe, one sleepy soul at a time. Now, close your eyes if you'd like. Breathe slowly, feeling yourself held by Earth's gravity, that same force that shapes galaxies and creates the structures we're about to explore. And let's begin our journey through the hidden architecture of the Milky Way. Hashtag the first shield, a bubble of million-degree gas. Look up at the night sky from the southern hemisphere, and you might see 2 fuzzy patches of light. They look like torn pieces of the Milky Way, floating separately in the darkness. Ancient sailors used them for navigation across the Pacific Ocean. We call them the Magellanic Clouds, and they're small galaxies, dwarf galaxies, orbiting our own. The large Magellanic Cloud sits about 160,000 light-years away. The small Magellanic Cloud is a bit farther, about 200,000 light-years. These distances are vast by human standards, but by cosmic standards, they're practically next door. Most galaxies are millions or billions of light-years apart. These two are close, very close, and our Milky Way has been slowly consuming them. When a small galaxy gets too close to a large one, gravity begins to pull at it, not just pulling on stars, but on the gas and dust between the stars. This gas is the raw material for making new stars. Take away the gas, and the small galaxy becomes a graveyard, all its stars eventually burning out with nothing to replace them. The Magellanic Clouds are moving through space at about 400 kilometers per second relative to the Milky Way. That's fast enough to circle Earth 5 times in 1 hour. At that speed, they should be leaving a trail of gas behind them, like a comet leaves a tail. And they are. Scientists have seen this trail with radio telescopes. It's called the Magellanic Stream, and we'll talk more about it soon. But something is strange. The Magellanic Clouds still have gas. Lots of it. They're still making new stars right now, today, as you rest here listening. The large Magellanic Cloud produces about half a sun's worth of new stars every year. According to calculations, this shouldn't be possible. These galaxies should have been stripped of all their gas billions of years ago. They should be dead, dark collections of old red stars. Between 2013 and 2020, astronomers studying these dwarf galaxies noticed something extraordinary. There was a bubble, a massive envelope of superheated gas completely surrounding both Magellanic Clouds. This bubble extends at least 100,000 light-years in every direction. That's as large as the entire Milky Way disk. And the gas in this bubble is heated to between 1 million and 2.5 million degrees. At those temperatures, atoms move so fast they slam into each other hard enough to produce X-rays and ultraviolet light. The bubble is glowing, but in wavelengths human eyes can't detect. It's invisible to us, but it's there, enormous and protective, wrapping around these small galaxies like a cosmic shield. And here's what makes it beautiful. This bubble is protecting the Magellanic Clouds. Think of it like riding a motorcycle through thick fog at incredible speed. The fog should tear everything apart. But if you had an invisible shield around you, the fog would hit the shield first and slide around it, creating a smooth path for you to travel through. That's what this hot bubble does. The bubble formed from gas that was already part of the dwarf galaxies. When they started moving through the outer regions of the Milky Way, the friction heated up their outer gas layers to extreme temperatures. This created a cushion. The hot gas is less dense than the cooler gas behind it, so it acts like a buffer zone. When the Milky Way's gravity tries to rip gas directly from the Magellanic Clouds, it hits this hot bubble first. The hot gas can't be stripped away easily because its particles are moving too fast, zooming around at thousands of kilometers per second. They're too energetic to be grabbed by the Milky Way's gravity. So the bubble stays intact, wrapped around the dwarf galaxies, taking the punishment that would otherwise destroy them. The bubble isn't perfect. It's more like an airbag in slow motion. The Magellanic Clouds are still losing gas, but the bubble slows down the process dramatically. Instead of losing all their gas in a few 100 million years, the dwarf galaxies can survive for several billion years. Long enough to keep making stars. Long enough to stay alive. As you rest now, imagine these dwarf galaxies wrapped in their protective cocoon, drifting through space at hundreds of kilometers per second, surrounded by gas so hot it glows with invisible light. The bubble has been operating for at least 2 billion years. It's older than complex life on Earth. It's been protecting these galaxies since long before the first animals walked on land. Let that vast timescale be comforting somehow. 2 billion years of continuous protection. A shield that arose naturally from physics, from the simple fact that friction creates heat and hot gas behaves in specific ways. No one designed it. No intelligence built it. It simply emerged from the laws of thermodynamics, from matter moving through matter, creating protection as a byproduct. The universe has built-in safety systems, natural buffers that slow down destruction and give cosmic structures more time to exist. And you're resting inside a galaxy that has these protections, that has been stable enough, safe enough for 13 billion years for stars like our sun to form, for planets like Earth to exist, for life to emerge and evolve. Let yourself be held by that knowledge. Let the ancient protection of the galaxy become your protection tonight. You're safe here, in this moment, sheltered by forces you can't see but that have been operating since before the sun was born, creating the stable conditions that made your existence possible. Breathe slowly. Feel the weight of your body supported by the bed beneath you, held by Earth's gravity, that same fundamental force that creates galaxies and protective bubbles and all the structure of the cosmos. And let yourself drift deeper into relaxation, carried by the invisible currents of space and time. ## the Magellanic Stream, evidence of ancient protection. If you had eyes that could see radio waves instead of visible light, and you looked up at the night sky from the southern hemisphere, you'd see something spectacular. A glowing ribbon stretching across more than half the sky. A river of hydrogen gas flowing from the Magellanic Clouds back toward the Milky Way, wrapping around our galaxy like a streamer caught in the wind. This is the Magellanic Stream, discovered in 1974 by astronomers using radio telescopes in Australia. They weren't looking for it. They were mapping hydrogen gas in our galaxy when they noticed something strange. A long arc of gas that didn't match any known structure, seeming to originate from the Magellanic Clouds and extending backward along their orbit. The stream is massive. It contains about 2 billion times the mass of our sun in hydrogen gas. Enough material to build 2 billion new stars. And it stretches across 600,000 light-years of space, making it one of the largest structures associated with our galaxy. Think about that distance for a moment. Light travels at 300,000 kilometers per second. At that speed, it would take 600,000 years to travel from one end of the stream to the other. If you started that journey when the first modern humans were walking around Africa, you'd still have 590,000 years to go. The stream forms because of the stripping process we talked about. As the Magellanic Clouds orbit through the Milky Way's outer regions, gas gets pulled away and left behind. That gas doesn't scatter randomly. It follows the gravitational field of the Milky Way, creating this long arc trailing the dwarf galaxies, flowing through space like a cosmic river. Now, here's the beautiful part, the part that proves the protective bubble is real and working. The stream exists, but it's not enormous. It's growing at a rate of about 1 sun's worth of mass every 10,000 years. That sounds like a lot, but it's actually surprisingly slow. If the Magellanic Clouds were being stripped at the rate you'd expect without any protection, they should be losing gas 10 to 20 times faster. The fact that the stream exists but isn't massive tells us something important. The stripping process is happening, but it's being slowed down dramatically. Something is protecting the Magellanic Clouds just enough to keep them alive while still allowing some gas to escape. That something is the hot bubble we explored. The bubble acts like a filter, like a brake. It can't stop all the gas from being stripped away, but it reduces the rate by about 80 to 90%. The gas that does escape to form the stream is mostly coming from the outer edges of the dwarf galaxies, where the bubble is weakest. The inner gas, where new stars are being born, stays protected. Recent detailed mapping showed structures within the stream. Clumps of denser gas, regions where the gas is moving faster or slower, places where the stream splits into multiple substreams. And most importantly, scientists could measure the age of different parts of the stream based on how far the gas has traveled from the Magellanic Clouds. The oldest parts of the stream, the gas that's traveled the farthest, is about 2 to 2.5 billion years old. That tells us when the Magellanic Clouds first entered the outer regions of the Milky Way and started losing gas. And it confirms that the protective bubble has been operating for at least that long. Imagine a cosmic river that's been flowing since before complex life existed on Earth. A stream fed by 2 dwarf galaxies that should have dried up long ago but haven't, because they're wrapped in a protective bubble of million-degree gas. The stream is like a scar, evidence of an injury that's been happening for billions of years. But the wound isn't fatal because the bubble is like a bandage that slows the bleeding enough to keep the patient alive. Eventually, the Magellanic Clouds will run out of gas. The bubble helps, but it doesn't completely stop the stripping process. In maybe 5 to 7 billion years, these dwarf galaxies will be dark and dead, having sacrificed all their gas to the Milky Way's gravitational pull. But without the bubble, they would have died 5 billion years ago. They're living on borrowed time, and the bubble is what bought them that time. As you rest now, let the image of this cosmic river carry you deeper into relaxation. A stream of hydrogen flowing through space for billions of years, glowing in wavelengths you can't see, telling the story of protection and sacrifice, of galaxies dying slowly instead of quickly, given extra time by the natural physics of hot gas and motion. The atoms that make up the Magellanic Stream will eventually fall back onto the Milky Way, where they'll be recycled into new stars. Planets that might form around those future stars will be built from material that spent billions of years in a different galaxy. If life develops on any of those planets, the atoms in their bodies will have traveled an incredible journey across hundreds of thousands of light years from one galaxy to another. In a very real sense, the Magellanic Clouds will live on through the Milky Way. Their material will be incorporated into our galaxy structure. Their legacy will be the stars and planets that form from their donated gas. And the hot bubble, by slowing down the stripping process, is ensuring that this transfer happens over a timescale long enough for both galaxies to benefit. Let yourself drift now, like gas drifting through the Magellanic Stream, carried by forces you don't control, following paths carved by gravity and motion, moving slowly through the darkness of space towards some distant destination. You don't need to know where you're going. You just need to let yourself be carried, surrendering to the flow, trusting in the process that has been working for billions of years. Breathe deeply. Feel your body becoming heavier, settling more completely into rest. And let the cosmic river carry you gently toward sleep. #the second shield, containing the monster at the center. Now we need to journey to the complete opposite end of our galaxy. From the quiet outer suburbs where dwarf galaxies orbit to the chaotic, dangerous center where a monster waits. The center of the Milky Way is 26,000 light-years away from Earth. If you could travel at the speed of light, it would still take you 26,000 years to get there. The galactic center is crowded, really crowded. Near the very middle, stars are packed so close together that if you lived on a planet there, you'd see thousands of stars brighter than Venus in your night sky. And right at the center of all that chaos sits Sagittarius A*, the supermassive black hole at the heart of our galaxy. It weighs about 4 million times as much as our Sun, but it's compressed into a region smaller than Mercury's orbit. The gravity near it is so strong that stars orbit at thousands of kilometers per second. Black holes have a reputation for being cosmic vacuum cleaners, but Sagittarius A* is surprisingly quiet. It's not eating much. Most of the gas that falls toward it gets deflected or heated up so much it blows away before crossing the event horizon. The black hole is essentially on a starvation diet. But just because it's not eating doesn't mean it's safe to be near. The region around Sagittarius A* is one of the most dangerous places in the galaxy, not because of the black hole itself, but because of cosmic rays. Cosmic rays aren't actually rays. They're particles, mostly protons, but these aren't ordinary protons drifting through space. These are protons accelerated to incredible speeds, sometimes reaching 99.99% of the speed of light. At those speeds, a single proton carries as much energy as a tennis ball thrown by a professional player. One subatomic particle packs the punch of something you can hold in your hand. When cosmic rays collide with things, they cause damage. Hit a planet's atmosphere in large enough numbers, and they can gradually strip away the protective layers, exposing the surface to deadly radiation. The galactic center produces a lot of cosmic rays. Sagittarius A* creates them when it occasionally eats a little bit of gas. There are also massive stars near the center that explode as supernovas every few thousand years, each one accelerating more particles to near light speed. By all rights, the galactic center should be radiating outward with a flood of these deadly particles, spreading through the galaxy like a wave, bombarding everything in their path. And for a long time, scientists thought that's exactly what was happening. Then in 2021, astronomers studying data from the Fermi Gamma Ray Space Telescope noticed something odd. There should have been way more cosmic rays spreading out from the center than they were detecting. The cosmic rays were being blocked. Something was stopping them from leaving the galactic center region. They called it the cosmic ray barrier, and it was completely unexpected. The pattern was clear in the data. Cosmic rays were being produced right near the black hole, but they weren't spreading out the way they should. Most of them were being trapped or deflected by something, unable to flood into the rest of the galaxy. Scientists came up with 3 main theories to explain this barrier, and the fascinating thing is all 3 theories might be correct. The barrier might not be one thing, but a combination of all 3 working together. First, the black hole itself might be blowing a wind that pushes cosmic rays back. When gas falls towards Sagittarius A*, some of it gets heated so much it blows away before reaching the event horizon. This creates an outflow, a wind of hot gas moving away from the black hole at thousands of kilometers per second. This wind can push against cosmic rays, slowing them down, trapping them within a few thousand light years of the black hole. Second, the magnetic fields near the galactic center are incredibly tangled. These fields are thousands of times stronger than what you'd find in our solar neighborhood. They get twisted by the motion of gas clouds and the rotation of the galaxy. Picture a labyrinth made of invisible walls that charged particles can't cross. The cosmic rays try to escape, but every time they move, they run into a magnetic field line that deflects them in a different direction. They bounce around like pinballs, unable to find a clear path out. Third, there's a giant ring of dense gas about 1,500 light-years from the center. This ring is dense enough that cosmic rays have a hard time getting through it. When high-energy particles try to pass through dense gas, they collide with atoms and lose energy. The ring acts like a thick stone wall surrounding a fortress, blocking cosmic rays from escaping except through specific channels where the gas is thinner. These 3 mechanisms working together create what scientists call a cosmic ray sea, trapped near the galactic center. The particles are confined by the combination of wind, magnetic fields, and dense gas, creating a barrier that protects the inner regions of the galaxy. Why does this matter? Because if those cosmic rays escaped freely, They'd make life much harder to sustain in the inner galaxy. Planets within 5,000 to 10,000 light-years of the center would be constantly bombarded by high-energy particles. The region protected by this barrier covers about 20,000 light-years in diameter, a sphere of space containing billions of stars and potentially trillions of planets. Without the barrier, every one of those star systems would be exposed to radiation levels dozens of times higher than what we experience here in the solar neighborhood. The cosmic ray barrier essentially makes the inner 20,000 light-years of the galaxy habitable. Not easy, not ideal, but possible. Without it, that region would be a radiation wasteland where life could only exist in the most extreme, sheltered environments. As you drift deeper towards sleep now, imagine that barrier, that invisible containment system holding back radiation that could flood thousands of light-years of space. It's been operating for billions of years, keeping the galactic center's dangers contained, allowing the inner regions of the galaxy to remain relatively safe. The barrier isn't static. It changes over time in response to what the black hole is doing. When Sagittarius A* goes through an active feeding phase, the wind gets stronger and the barrier becomes more effective. When the black hole is quiet, like it is now, the barrier weakens slightly and more cosmic rays leak out. About 6 million years ago, Sagittarius A* apparently ate something large, maybe a gas cloud or a star that wandered too close. The feeding event created a massive outburst of energy that strengthened the barrier and cleared out cosmic rays from a huge region around the center. The effects of that outburst are still visible today in the form of giant gamma-ray bubbles extending above and below the galactic plane. Let yourself relax into the knowledge that even the most dangerous place in our galaxy has natural protection, that the universe creates barriers where they're needed, that the same physics that creates black holes also creates mechanisms to contain their most harmful effects. You're safe here, lying in the darkness, held by Earth's gravity, shielded by Earth's atmosphere and magnetic field, protected by the vast distances of space, living in a galaxy that has multiple layers of defense against cosmic dangers. The black hole at the center is contained. The cosmic rays are trapped, and you can rest peacefully, knowing that the galaxy has been taking care of itself for billions of years, creating stability, maintaining balance, allowing stars and planets and life to exist in relative safety. Breathe slowly. Feel your heartbeat, steady and calm, and let yourself sink deeper into the peaceful darkness of approaching sleep. Hashtag the third shield, the mysterious edge. For the past 15 years, scientists operating the Pierre Auger Observatory in Argentina have been collecting data on the most energetic particles in the universe. These ultra-high-energy cosmic rays carry so much energy that a single subatomic particle can hit with the force of a baseball thrown at full speed. The observatory isn't like a normal telescope. It's a cosmic ray detector spread across 3,000 square kilometers of Argentine grassland, an area bigger than the entire country of Luxembourg. It uses 1,500 water tanks arranged in a grid pattern across this enormous space. When an ultra-high-energy cosmic ray hits Earth's atmosphere, it creates a cascade of secondary particles. When these particles hit the water in the tanks, they produce flashes of light that sensors can detect. By analyzing which tanks got hit and in what order, scientists can figure out where the cosmic ray came from and how much energy it had. The observatory has been running since 2008, slowly collecting data on the most energetic particles in the universe. These particles are rare. You might detect 1 per square kilometer per century, so having 3,000 square kilometers of detectors is necessary. What makes these observations fascinating is what they reveal about the boundaries of our galaxy. When scientists map where these ultra-high-energy cosmic rays come from, they're essentially mapping the edges of cosmic structures. Some particles come from within the Milky Way. Some come from outside, from distant galaxies millions or billions of light-years away. And the boundary between inside and outside matters more than you might think. The Milky Way isn't just a collection of stars floating in empty space with a sharp edge where everything stops. The galaxy fades gradually into intergalactic space. There's a transition region where the density of matter drops, where magnetic fields change their structure, where the environment shifts from galactic to intergalactic. This boundary region has properties we're only beginning to understand. The magnetic field of the Milky Way extends far beyond the visible stars, creating an invisible structure that can affect charged particles. When cosmic rays traveling through intergalactic space encounter this field, they can be deflected, slowed down, or trapped depending on their energy and trajectory. Scientists studying data from the Pierre Auger Observatory and other cosmic ray observatories around the world have noticed patterns. The distribution of cosmic rays arriving from different directions isn't random. There are preferences, more particles from some directions, fewer from others. The energy distribution shows features that suggest something is filtering or organizing the incoming particles. But here's the challenge. We don't fully understand what's causing these patterns. There are several possibilities, and scientists are still working to figure out which explanation is correct. The magnetic fields at the galactic boundary might be stronger or more organized than we thought. At the edge of the galaxy, where gas density drops off and the environment transitions from galactic to intergalactic, the magnetic field might be forming a boundary layer where field lines are compressed in ways that deflect incoming particles more effectively than simple models predict. Or perhaps dark matter at the galactic edge is somehow affecting cosmic rays. Dark matter is the mysterious substance that makes up about 85% of all matter in the universe. We can't see it directly because it doesn't emit or absorb light. The Milky Way is surrounded by a halo of dark matter extending far beyond the visible stars. Maybe dark matter particles interact with ultra-high-energy cosmic rays in ways we haven't discovered yet. Or perhaps the transition from galactic to intergalactic environments creates conditions we haven't fully accounted for in our models. The boundary region is complex. Gas density changes, magnetic field structure changes, the intensity of starlight changes. When you have sharp gradients in physical properties, you can get unexpected behaviors. Most likely, we're seeing the combined effects of multiple factors working together. Magnetic fields deflecting some particles, the edge of the dark matter halo affecting others, plasma conditions at the boundary scattering particles in certain energy ranges. The real answer might be a complex mixture of all these factors, each one contributing to the overall pattern. This is frontier science, still being explored, still being understood. We're studying the boundary of our home galaxy using the most energetic particles in the universe as probes. Every new cosmic ray detection adds to our understanding. Within the next decade, new observatories will give us much better data, helping us understand exactly what's happening at the edge of our galaxy. Why does this matter? Because understanding the boundary of the Milky Way tells us fundamental things about how galaxies work. If the edge affects what can enter the galaxy, it influences how galaxies grow and evolve. It also matters because the patterns we see might be common to all spiral galaxies. The Milky Way is the one galaxy where we can measure these effects in detail because we're inside it. As you rest now, think about being inside these structures, surrounded by invisible shields operating at every scale. The hot bubble protecting satellite galaxies, the cosmic ray barrier containing radiation from the center, and now this mysterious filter at the galactic boundary, mediating the interaction between our galaxy and the wider cosmos. You're not floating in empty space. You're inside a structured system, a galaxy where natural processes have created stable conditions for billions of years, giving matter the time and space it needed to organize itself into stars, planets, and eventually living things that could look up and wonder about their place in the universe. Let that structure support you as you drift toward sleep. Let the knowledge that the galaxy is protected, that it has boundaries and shields and natural defenses, become a source of comfort. You're held by more than just your bed, more than just Earth's gravity. You're held by the architecture of the galaxy itself, by forces that have been operating since before the sun was born. Breathe deeply. Let your body become heavier, settling completely into rest. And let yourself be carried across the boundary from waking into sleeping, from consciousness into dreams, crossing that threshold as easily as light crosses the edge of the galaxy, moving from one state to another without effort, without resistance. Hashtag the thought experiment. What if the shields failed? Let's imagine something together, a gentle thought experiment as you drift toward sleep. Imagine all three of these protective structures disappear tomorrow. The hot corona around the Magellanic Clouds vanishes. The cosmic ray containment at the galactic center collapses. the boundary effects at the galactic edge stop working. What would happen? Without the hot corona, the Magellanic Clouds would lose gas dramatically faster. Within the first 10 million years, the Large Magellanic Cloud would lose 50% of its remaining gas. Star formation would drop. The bright blue regions where massive young stars currently shine would start to fade. The Small Magellanic Cloud would fare even worse, losing 70% of its gas in the same time frame. By 50 million years after the bubble disappears, both dwarf galaxies would be functionally dead. They'd still have stars, billions of them, but those would all be old stars that formed before the disaster. No new stellar nurseries. No new planets being born around young stars. No new chances for life to develop. The Magellanic Stream would change too, doubling in size within 20 million years as all that stripped gas flows away. Eventually, this extra gas would fall back onto the Milky Way, creating bursts of star formation in the outer regions. Parts of the galaxy would look different, more chaotic, less elegant. At the galactic center, if the cosmic ray barrier collapsed, billions of cosmic rays that were trapped near Sagittarius A* would start spreading outward in all directions. Within 5,000 years, cosmic ray intensity in the inner 10,000 light-years of the galaxy would increase by a factor of 50. Any planets in that region without strong magnetic fields would get bombarded with high-energy particles that strip away their atmospheres. Earth would be safe. We're 26,000 light-years from the center, far enough that the intensity increase would be noticeable to scientists but not enough to cause immediate harm. But the inner galaxy wouldn't be safe. Star systems within a few thousand light-years of the center that might have had a chance of hosting life would be sterilized. At the edge, if the mysterious filter at the galactic boundary stopped working, ultra-high-energy cosmic rays from intergalactic space would pour in. These particles would slam into the outer halo of the Milky Way and dump their energy as heat. The temperature of the gas would increase, the pressure would rise, and over the next 100 million years, the outer halo would expand outward. The galaxy would become puffier, less tightly organized. All three failures combined would create a cascade effect. The galaxy would lose the Magellanic Clouds as functional satellites. It would develop a radiation problem in the core. It would start puffing up and losing mass from the edges. Over the next billion years, these effects would compound. The Milky Way would remain a spiral galaxy, but a diminished one, smaller, less organized, with less star formation and fewer opportunities for planets and life. But here's the beautiful thing. This thought experiment isn't going to happen. These structures have been operating for 13 billion years. That's longer than Earth has existed. They're not artificial constructs that can fail. They're natural features of galactic physics, formed by the interplay of gravity, motion, magnetic fields, and the properties of hot gas. The hot corona exists because physics requires it. The cosmic ray containment exists because of wind, magnetic fields, and dense gas. The boundary effects appear to be properties of how galactic and intergalactic environments interact. Whatever the mechanisms, they're apparently stable enough to have operated for the galaxy's entire lifetime. These shields will keep working long after humans are gone, long after Earth is swallowed by the dying sun in 5 billion years, long after the sun itself burns out. The shields will still be there, quietly doing their job, protecting the Milky Way and giving it time to evolve at its own pace. That's comforting when you think about it. The universe has dangers, but it also has protection systems, shields that arise naturally from the laws of physics. And those shields have kept our home galaxy safe for longer than life has existed anywhere in it. As you drift now, deeper and deeper towards sleep, let yourself be held by that permanence. The shields aren't going anywhere. They'll be operating tomorrow, and the day after, and a billion years from now. You can rest completely, knowing that the galaxy is stable, protected, maintained by forces as reliable as gravity or magnetism, as permanent as the laws of physics themselves. Let your breathing become slower, deeper, more automatic. Feel your body becoming heavier, supported completely by the surface beneath you. And let yourself sink into the deep comfort of knowing that you exist inside a protected system, inside a galaxy that has been stable and safe enough for billions of years for complexity to emerge, for life to develop, for consciousness to arise and wonder about its place in the cosmos. You're safe. The galaxy is safe. Everything is held by natural forces that have never failed and never will. And you can let go completely, surrendering to sleep, trusting in the ancient protection that surrounds you at every scale. Hashtag the future, seeing the invisible. Between 2026 and 2035, something remarkable is going to happen. Multiple space missions and ground-based observatories scheduled to come online will give us the ability to directly image these shields for the first time in human history. We're going to watch them work in real time. New X-ray telescopes will be able to create detailed maps of the hot corona around the Magellanic Clouds, showing how hot the gas is in different parts of the bubble, measuring temperature variations down to a precision of 1%. Scientists will be able to see where the bubble is being compressed and where it's thinner and more vulnerable. The next generation of gamma-ray telescopes will revolutionize our understanding of the cosmic ray barrier at the galactic center. These telescopes will observe the galactic center for hundreds of hours, building up detailed images showing exactly where cosmic rays are concentrated and where they're being blocked. And new cosmic ray detectors will help us understand the mysterious filter at the galactic edge, measuring not just where particles come from, but what they're made of, helping determine whether the filter is caused by magnetic fields, dark matter, or something else entirely. For the first time in history, we're about to see the invisible. The shields that have been protecting our galaxy for 13 billion years are about to become visible, not to our eyes, but to our instruments. And what we learn will fundamentally change how we understand galaxies, how they evolve, how they protect themselves, and how they create conditions that allow stars, planets, and life to exist. But even now, with our limited knowledge, we can appreciate what we've learned. The Milky Way takes care of itself. It has mechanisms built into its structure that protect it from both internal and external threats. It's a galaxy that has survived for 13 billion years, not through luck, but through the natural operation of physical laws that create shields, barriers, and filters wherever they're needed. As you rest now, as consciousness begins to dissolve, let yourself feel connected to this protected space. You're inside these shields right now. You always have been. They've been operating since before the sun was born, creating stable conditions, moderating extreme environments, allowing the galaxy to evolve slowly enough that planets like Earth could form and persist for billions of years. You're not just lying on a bed in a room on a planet. You're inside a galaxy that has natural defenses, that has been protected for longer than you can comprehend, that has created conditions stable enough for the miracle of complexity, the emergence of life, the development of consciousness that can look outward and understand its place in the cosmos. Let that knowledge settle over you like a blanket. Let it be the last thought that drifts through your mind before sleep finally takes you. You're held by the galaxy, protected by shields you can't see, surrounded by forces that have never failed, and that will continue operating for billions of years after you're gone. The hot corona wraps around satellite galaxies. The cosmic ray barrier contains radiation from the center. The galactic boundary filters incoming particles. And you're inside all of it, safe in the structure, held by the architecture of the cosmos itself. Hashtag you are made of protected stars. Every atom in your body has a history that connects you to these shields. The hydrogen in your water molecules was formed in the first few minutes after the Big Bang. The carbon in your cells was forged in the hearts of massive stars that lived and died billions of years ago. The iron in your blood was created in supernova explosions that scattered material across thousands of light years. You are not separate from the galaxy. You are made of it, made of atoms that were once part of stars, that drifted through the interstellar medium, that eventually came together to form the sun and Earth and you. Every element heavier than hydrogen and helium was created inside stars or in supernova explosions, then spread through the galaxy by stellar winds and supernova shock waves. The story of these elements is the story of cosmic protection. Without the shields we've explored tonight, without the hot bubble and the cosmic ray barrier and the galactic boundary effects, the galaxy would be more chaotic, more dangerous, less stable. Star formation would be more erratic. Supernova rates would be different. The chemical enrichment of the interstellar medium would follow different patterns. The atoms that eventually became you were protected on their journey through the galaxy, protected by the same shields that operate today. The stability of the Milky Way over billions of years allowed those atoms to cycle through multiple generations of stars, gradually building up the heavier elements needed for rocky planets and complex chemistry. Without that stability, without that protection, you wouldn't exist. The atoms might still be scattered through the galaxy, might still be cycling through stars, but they wouldn't have come together in the specific pattern that is you, living on a stable planet orbiting a stable star in a protected galaxy. Let yourself feel that connection now. You're not isolated from the cosmos. You're an expression of it, a temporary pattern formed from stellar ashes, a brief organization of matter that can think and feel and wonder. The galaxy made you from its substance. The shields protected the process. And here you are, resting peacefully, contemplating your origins, drifting towards sleep. Every breath you take contains atoms that have traveled through the galaxy, that have been part of different structures, different molecules, maybe even part of other living things long ago. You're constantly exchanging atoms with the environment, with the air, with the food you eat and the water you drink. You're not a fixed thing but a process, a pattern that persists even as the specific atoms that make it up are constantly being replaced. This is true at every scale. The galaxy itself is a process, not a fixed object. Stars are born and die. Gas flows through the interstellar medium. The spiral arms rotate. Everything is in motion. Everything is changing, but the overall structure persists, maintained by gravity and rotation and the laws of physics. And the shields persist too, self-maintaining systems that arise from the physics of hot gas and magnetic fields and the motion of matter through space. They're as much a part of the galaxy's structure as the stars themselves, invisible but essential, creating the conditions that allow everything else to exist. As you drift now, deeper into sleep, let yourself dissolve into that flow. You're not separate from the process. You're part of it, a small temporary pattern in the vast cosmic dance. And you can let go, surrendering to the flow, trusting in the forces that have sustained the galaxy for billions of years, knowing that those same forces will continue long after you're gone. Your atoms will return to the Earth, then eventually to space. They'll be part of other things, other patterns, other expressions of matter organizing itself. Nothing is truly lost. Everything cycles, everything flows, everything continues. And right now, in this moment, you're here. Conscious, aware, resting peacefully in the darkness, held by the Earth, sheltered by the atmosphere, protected by the galaxy's invisible shields. You're exactly where you need to be, doing exactly what you need to do, which is nothing except breathe and rest, and let sleep come when it's ready. Hashtag the deep peace of cosmic time. As we near the end of our journey through the invisible shields of the Milky Way, let yourself sink into the deepest peace. You've traveled far tonight, from the hot corona around the Magellanic Clouds to the cosmic ray barrier at the galactic center, from the mysterious edge of the galaxy to the atoms in your own body that carry the history of stars. You've learned about structures that have been operating for 13 billion years, protecting our galaxy, creating stable conditions, allowing complexity to emerge. You've seen how physics naturally creates shields, how the universe has built-in safety systems, how matter and energy organize themselves in ways that preserve structure rather than destroy it. And through it all, you've been resting, relaxing, letting your body and mind prepare for sleep. Your breathing has become slow and automatic. Your muscles have released their tension. Your thoughts have become less focused, more dreamlike, drifting like gas clouds through the interstellar medium. The galaxy is protected. You are protected, and you can rest completely in that knowledge, letting go of any remaining tension, any lingering worry, any thought that keeps you from fully surrendering to sleep. The Magellanic Clouds orbit through space wrapped in their hot corona, safe for another few billion years. Sagittarius A** sits at the galaxy's center, its radiation contained by wind and magnetic fields and dense gas. The galactic boundary filters incoming particles, maintaining the distinction between our galaxy and the universe beyond. And you rest here, inside all of it, held by forces you can't see but that have never stopped working. 13 billion years. That's how long these shields have been operating. Longer than Earth has existed. Longer than the sun has existed. Longer than most of the stars you can see in the night sky. The shields were there when the first stars ignited, when the first planets formed, when life first emerged on Earth, when the first humans looked up at the sky and wondered what was out there. And they'll be there long after you're gone. long after everyone you know is gone, long after humanity itself is gone. The shields will continue operating, protecting the galaxy, creating stability, allowing new stars to form, new planets to coalesce, new possibilities to emerge. There's something deeply comforting about that permanence. Your individual life is brief, but you're part of something vast and enduring. The galaxy will continue. Life will continue. The universe will continue its slow evolution from simple to complex, from uniform to diverse, from low entropy to high entropy over timescales that dwarf human comprehension. And you get to rest now, knowing that you've played your part, that you've been part of the cosmic story, that the atoms that make up your body will continue in new forms long after the pattern that is you has dissolved. Nothing is lost. Everything continues. And you can let go completely, trusting in that continuity. Feel your breathing, so slow now, so deep, so automatic that you barely notice it. Feel your heartbeat, steady and calm, pumping blood through your body, carrying oxygen to your cells, maintaining the processes of life while you rest. Feel the weight of your body, heavy and relaxed, supported completely by the surface beneath you. You don't need to do anything. You don't need to think about anything. You don't need to remember these facts or worry about these concepts. The shields will continue operating whether you think about them or not. The galaxy will continue evolving whether you're awake or asleep. And right now, sleep is what you need, what your body is calling for, what your mind is ready to embrace. Let the last remnants of consciousness fade away. Let thoughts dissolve like morning mist in sunlight. Let awareness narrow and dim and finally disappear into the soft darkness of deep sleep. The invisible shields of the Milky Way have been standing guard for 13 billion years. They'll watch over you tonight as you rest, as you dream, as you surrender completely to the ancient rhythm of sleeping and waking. You're safe. The galaxy is safe. Everything is held by forces as old as time, as reliable as gravity, as permanent as the laws of physics. And you can sleep now, deeply and completely, knowing that when you wake, the shields will still be there, still operating, still protecting, still maintaining the delicate balance that makes life possible in this vast and ancient cosmos. Good night. Rest well. And let the invisible shields of the Milky Way carry you gently through the night, protecting you as they've protected everything in the galaxy for billions of years, creating the stability and peace that allows you to let go completely and sleep. Deep, profound silence. The eternal watch of invisible shields. The peace of 13 billion years of protection. The beginning of sleep.